we have a number of situations where payments are going to be constant each and every period. And in that case, we are attempting to discount a bunch of things here, particularly for a long period of time. It's easy to just take advantage of formulas that have been derived to satisfy this for an annuity. And an annuity is just an annual payment that's going to be constant. Here we've got a problem where it asks us to find the present value of these ordinary annuity. Now, by ordinary annuity, what it's talking about is the normal assumption that we have that cash flows occur at the end of the period. We want to contrast that for what is known as an annuity due, where the payment comes up front. So you may want to think of this where if you had something like a mortgage, for example, you pay at the end of the period, versus if you had rent, you pay at the beginning of the period. Now, to be able to deal with these, we do have a function in Excel that's going to be able to make this quite easy for us. And what we're going to see is that within that family of functions that we've already seen with the rate function, one of the things that fit in there was something called PV, the present value. And that would be the case where we're dealing with an annuity. So we want to go to our function wizard, and we want to go under the financial menu all the way down until you see something that says PV for present value. Now the PV function is the one that is appropriate for an annuity, and we're going to see plenty of circumstances with this, most notably when we get into bonds behavior. And you'll see that the arguments are rate, which is the annual interest rate, or the periodic interest rate, let me put it that way, NPER, which is the number of periods, how long does this last, what is the payment or the amount of the annuity each period, and future value is referring to, is there a lump sum that comes at the end, some type of balloon payment, and type is asking us whether it's an ordinary annuity or an annuity due. So let's go ahead and put this in place here. And what we want to be choosing for rate is simply the information that appears in the column for R. For the number of periods, this is N. Typically we're going to use N to be years, and since we're talking about an annual basis here, that's all we would need. Payment, and again, we need to make sure that payment and FV are of the same sign, and that they're the opposite sign as the present value. Now, since we're looking for the value in a positive sense, what we're going to look at here is giving up a particular amount. So we're going to treat this as a negative, and we'll put it as a negative of the annuity amount right there. And once we have that, there is no lump sum, so we don't need to put anything there. And when we come down to type, it assumes that payments are happening at the end of the period, what would be an ordinary annuity, unless we tell it otherwise. So this is just a 0-1 value. 0 means payment at the end of the period, or if you don't put anything in, it assumes 0. So we can simply assume that. And you'll see there's the value that we're going to get for this annuity. Now we can pop this in place, just copy and paste that in place in here. So 5 annual payments of $200 when the interest rate is 5% is going to give us this amount right here. And since all of these were givens, I'm going to put those in blue for that consistency that we have in all of our problems, where I'll take any given number will appear in blue so we know where that comes from. In this case, if we had $400 a year for 5 years and no interest involved, we're simply going to get there's no discounting. So it's going to be our $2,000. So when I copy and paste that in place, nothing has been discounted. Now, in the case of the annuity due, it's very similar as to what we're going to be doing here. Again, we're going to go back under our most recently used to that PV function. And under the PV function, we again want to pick up the rate that we had. Number of periods, we still want to pick up N. And payment, this is going to be an outlay of the amount that fits there. But the key comes down here when it comes to type. And what we're going to do is we're going to receive these up front. So when you're getting the value up front, we're going to anticipate if there's any positive interest that the value is going to be higher. So we anticipate something higher than this 2457, and indeed we're going to get it at 2703. And that would be the case of an annuity due. So the big thing is this type is being indicated as payment coming up front. Now we can copy and paste that in place. You can see the same relationship going on there. However, in this last one, we're still going to get $2,000 because there is no discounting. If there is no interest rate, then it makes no difference whether you got it up front or at the end of the period. and you can see the $2,000 value.